Nuclear power produces 17% of the world's electricity. Like any other form of power generation, it produces waste. Even though the volume of waste is small, it needs to be isolated for long times until the radioactivity decays. What can be done? Clearly, the fate of this material is something which should concern the whole world, and Pangea is an organization devoted to promoting a safe world solution to the problem. After the fuel has been generating electricity for several years in a nuclear power station, it must be replaced by new. This used or spent fuel can be sent for disposal. Alternatively, the fuel can be recycled by reprocessing. This segregates the reusable materials from the waste requiring disposal. The solid waste is encapsulated in concrete or formed into solid glass blocks within stainless steel containers. In the case of used fuel from reactors, the fuel is conditioned and packaged. After around 200,000 years, these materials are no more radioactive than many naturally occurring ores. In human terms, 200,000 years is a very long time, but it is a very short time in geological terms. For instance, the waste would be able to decay 5 times during 1,000,000 years, a short time in the life of a rock. For geological disposal to be viable, the waste must be held by its containers and the geology around it such that the nuclear materials in it never return to man's environment to cause harm. Can geological disposal be proved to be safe, not only to scientists, but to the public at large? The key issue both with scientists and the public is to be able to prove that the waste will remain isolated from the environment for the very long times necessary for it to lose its radioactivity. Pangea looked at all the ways that radioactivity could in fact return to the environment and asked the question, can we find places in the world where this doesn't happen? The major concern with geological disposal is that mechanisms could exist which would allow radioactivity from the waste back to the surface. This would generally occur by the waste dissolving in groundwater, which would subsequently migrate to the surface. Migration in groundwater is most serious when there is high rainfall, permeable rocks, and hills or mountains to drive the water flow. There is also concern about the stability of current geological structures. What about earthquakes, climate change, glaciation, mountain building? All these could change the processes affecting the waste in the ground and make it harder to be certain about the long-term safety of the repository. We must clearly avoid areas of significant oil or mineral deposits, as this might encourage drilling or mining in the future. So, we are looking for large, flat, remote areas with very stable and long-lived geology, no economic mineral resources, with an arid climate, and no prospect of short-term climate variation and glaciation. Where are such areas to be found? All these considerations lead to the conclusion that Australia can provide the best world site for a geological repository for nuclear materials. Australia has experience in the nuclear field, from uranium mining. These areas of Australia are flat, remote, have been arid for at least 2 million years. Pangea is focusing on the areas of Pangea geology in South and Western Australia, with access from either the northwest or southwest. The waste containers will then be transported in highly engineered rugged transport containers called casks. These transport casks typically weigh 100 tons and carry just 5 tons of nuclear material. Once unloaded at the port, the casks will travel on a dedicated rail line several hundred kilometers to the repository site. At the site, there will be a dedicated store where the nuclear materials in their stainless steel containers are removed from the massive transport casks and stored, awaiting emplacement in the repository. The nuclear material containers will be placed in overpacks before disposal. The repository consists of a system of tunnels and caverns excavated deep underground. Australia possesses a unique combination of natural, political and infrastructural factors, which make it the world best for the task. Pangea, leading a global solution for the disposal of nuclear materials.